Hi everyone, welcome. Good to see you all again. I'm sure we'll get a couple more coming through in the next few minutes. So my name's Daniel. As you all know, I see a lot of familiar names from previous weeks. So let's begin. So this is the 5th lesson in this Mathspace Academy series for Year 9, and we're finishing our work with algebra today. Okay. So before we start, I had a lot of requests for challenging questions for me to ask. Now, normally I'll do it at the end from now on, but I know I didn't give you a challenging question last week and I promised you I would. So I want you to write this down. I'm going to leave this up on the screen for about a minute. Okay. Just 1 minute for you to write this down in your books, and then it's up to you. You can give me the answer at the end of today's session, or maybe you could do it at the start of next week. It's up to you. I still want you to be following along with today's lesson. I don't want you to be kind of not listening to what I'm saying and trying to be working on this challenging problem instead. But I just wanted to give you this challenging problem. So write it down in your books, and if you've got time, you're welcome to give me this answer at the end. I've got the answer in my book. So otherwise, yeah, you can always take it over the week and we can talk about it before next week's lesson, before it starts. Okay. So just another minute. I'll leave this on the screen because there are a lot of variables. Okay. I want you to expand the following binomial expression. So remember binomial expansion. That's what we did last week. You need to use that to expand the brackets here. Okay, just giving everyone a few more moments to write this down in their notes. Okay, all right, I'm going to keep going. I can pull this up at the end of today's presentation if anyone didn't get a chance to write it down, but I'm hoping that you all got a chance to write it down. Okay, so welcome, it's me again. Mathematics educator at Mathspace. I've created lots of worked examples in our online textbooks. And yeah, I am your Year 9 teacher. So just some of that housekeeping that we always do at the start, guys. So remember, these are recorded. So if your internet connection does drop out, or if you're not able to stay for the whole lesson, or you ever miss a lesson, okay, these sessions are recorded and usually available 24 hours later. So the recording of this session will be uploaded tomorrow on Friday. So I'm following the Mathspace curriculum. So I'm looking at the Mathspace textbooks and I'm using them to help me just plan these lessons. Okay, so we're doing more algebra. So it might have been that you already did all the algebra work in the start of term 1, or maybe you're still doing it now. And if you're in Year 9, you know, maybe you're doing it later in the year. So even if you haven't done it yet, I recommend sticking around because you'll definitely learn something and then it'll help you when you actually do cover it in class. Okay. So I'm going to be asking questions as usual. It's been really working well the last few weeks where I'll pose a maths question to you and then you write me the answer in the chat. Okay. And so we're going to keep doing that. And if you've got any other questions, you can leave it in the Q&A box in Zoom. Okay. Let me just double check everything's all right. Yep. Great. So we're beginning our 5th lesson and we're finishing algebra. So last week we worked on expanding the brackets to get algebraic expressions. We did that using the distributive law and also binomial expansion. Now we're going to go the other way. We're going to factorize algebraic expression using the highest common factor, and also we're going to use grouping. Okay. So what are we doing today? Today is factorizing as well as factorizing by grouping. So I've taken inspiration from the Mathspace curriculum, chapter 2 of the Australian Year 9 curriculum, lessons 5 and 6. And so next week, we're going to be starting our work on Pythagoras' theorem. Okay, so we'll do some basics of Pythagoras and also just how to find the hypotenuse of a right angle triangle using Pythagoras' theorem. So I always do this little plug at the start. For any of you who want to do any additional study outside of these lessons, you can come to wootube.mathspace.co and you can watch some of Eddie Woo's videos. So you may have already watched the first 4 lessons because that's what we've covered in Mathspace Academy already. You could now, after this lesson, if you want to learn more, go into deeper detail, is that you can do now the 3 videos in 2.05 and then the 3 videos in 2.06. And that way you can learn more about factorising, more than we can cover in this 1 hour session. So just going back to last week's work of the distributive law, okay? So remember when you had this factor A out the front and you multiply by a sum or a difference in brackets, you take each of those terms in the sum or the difference and you multiply by that factor, okay? So remember, you know, you take that A and you multiply by B, and then you take that A and that creates AB. And then you take that A and multiply by C, and that creates the AC. Okay, so this is just some revision from the previous weeks. So to factorize, we need to look at the distributive law in reverse. Okay, so AB plus AC, when you factorize, you're taking out a highest common factor. Okay, so you're taking out this factor of A out the front, and then you just have that sum left over. So you're basically dividing A from both of the terms, and then you take that A out the front, and then what's left is in the brackets, okay? So that's it for now. Yep, we'll revise binomial expansion a little later, okay? So now I'm going to work on some questions in Mathspace. I have to quit this, that's right. Okay, so what is the highest common algebraic factor of 2A and 3A? Okay, so everyone who's here today, I would like you to answer that in the chat box. So before we do the factorization using the distributive law, okay, before we do that, I just want to practice first identifying a highest common factor. So when looking at 2A and 3A, I know 2 and 3 are prime numbers, okay? So there's no common factor between 2 and 3 because they're both prime numbers, okay? However, both share this A term. So a couple of people are getting the answer right. I can see Ray's got the answer right, and so has Remy, okay? This is the highest common factor. The highest common factor is equal to A. So A, as an algebraic factor, is the highest factor that can be divided out of both terms. I can see some people have said 2 or 2A. You see, you could divide the first term by 2, but if you divide the second term by 2, it doesn't work because you would leave a fraction 3 halves, right? 3 has no factors of 2. Okay, so you can't use 2 or 2A, okay, it has to be A. So the answer is A. A is the only term that can be divided out of both 2A and 3A, so it is the highest common algebraic factor. Okay, so let's do another one. Okay, this one's a little trickier, okay? So what is the highest common factor of 11n squared ma and then 13xn squared b? All right, so you need to look at these two algebraic terms and give me the highest common factor. Okay, so note 11 and 13 again are prime numbers, and so one is not a multiple of the other, so there's no common factors there. Okay, I see m only appear on the left-hand side, not the right-hand side. X only appears on the right-hand side. Okay, A only appears on the left-hand side. B only appears on the right-hand side. So there's actually only one common factor. It is the n squared. Okay, so n squared could be divided out of both terms successfully. So I could divide n squared out of both to cancel it out, right? And that's what we'll be doing when we do the factorization. So that highest common factor must be n squared. So well done, Remy, Yusuf, Ray. I see that you got the answer correct. So n to the power of 2. You can't just say n, okay? Because n is squared in both of the terms, okay? So then technically a common factor is n. You could divide n out of both terms, but it's not the highest common factor because you see n appears twice as a squared, right? So n squared can be divided out of both terms. So that's why n squared is the highest common factor, okay? So I can write that in as my answer, n to the power of 2. Great, so we'll do a couple more of these examples before we start factorizing. So then what would be the highest common algebraic factor of 10bx and 15xy? So we're looking at 10bx and 15xy. I can see some people are writing in the answer already, which is great. Well done, Yusuf, Ray, Remy. So one common factor is x. Okay, that's easy. I can see x appearing in both terms. However, I know 10 is divisible by 5 and 15 is divisible by 5. So we have two common factors, okay? We have x and we also have 5. So then the highest common factor is always the product of all the known factors. So 5 times x, I can divide out 5x, the product of these two common factors from both terms, okay? So that means the highest common factor is 5 times x, which in algebra we write as 5x. We bring those terms together, okay? So quite often when we take out a highest common factor, it is not a single number. It is often a product of several numbers, okay? I can see some people raising their hand in Zoom. If you've got a question, rather than me stopping and asking you what the question is, I'm going to keep going. But if you've got a question, please write it in the Q&A box, or you can write it in the chat box, and then I can make a note of it because there's not too many of you here. But I would prefer it if you used the Q&A box. Okay. Okay. What is the highest common factor of these two terms? So now we're getting trickier, right? We're looking at the first term, which is 16 times a times m squared times n to the power of 7 times x cubed. And then the other term is 12a to the power of 4b squared, a single x, and then y to the power of 7. Yeah, yep, Ray, Yusuf, Remy, well done. That is correct. Good, very good. Okay, so I will now show you the answer. Okay, so I see that A appears once, okay, and then it appears as a to the power of 4 on the right-hand side, okay? So I can't take out a squared or a cubed or a to the power of 4. That doesn't work because there's only the one a in that first term, okay? So I can only divide out a. So one common factor I see is letter A, okay? M only appears on the left-hand side. B only appears on the right-hand side. N only appears on the left-hand side. Y only appears on the right-hand side. But they do both share X as well. Now, X I see in that second term. And then in the first term, I have X to the power of 3. But again, I can't take out X squared or X cubed, okay, because it only appears once as an X on the right-hand side in that second term. So I can't take those out as a factor, but another common factor would be a single X. You could divide X from both terms. Finally, 12 and 16, they are both multiples of 4, okay? So that highest common factor of 12 and 16 is 4, okay? Be careful, it's not 2, all right? You can divide 16 and 12 by 2 to get 8 and 6, but then you can divide both of those by 2 again to get 4 and 3. So 4 is that common factor as a number. So then the highest common factor becomes the multiple, the product of these 3 common factors. So 4ax. Okay, so I saw some of you got that right. Well done. So then that highest common factor is 4ax. Okay, great. Let's move on to the next question. Now we're going to start factorizing, okay? So there's going to be 2 steps. You have to identify that highest common factor. Then you need to use the distributive law, which I had on the slides before. So when you have a highest common factor in a sum or a difference, you can take out that highest common factor out the front, and then you're left with those terms with the a divided out. So I can already see Yusuf, Ray, you have got these. This is correct already. You have successfully factorized. Well done. Same as you, Remy. For everyone else, let me show you how this is done. Okay. So with the w squared plus 4w, I first need to find that highest common factor of these 2 terms, w squared and 4w. Okay. So what would be the highest common factor of these 2 terms? So please write that in the chat box. For those of you who come up with the answer, you don't have to do it, but yeah. So that's right, Yusuf, correct. Remy, yep. Ray, the highest common factor is w. Okay, I can divide w from both terms. Okay, so then that means I'm going to have w out the front and then these 2 numbers being added. Okay, so with the w squared, okay, I've divided out a w. And then with the 4w, I have divided out common factor w, okay? So then what happens is those w's cancel, and then w squared divided by w just leaves w, okay? So then my answer becomes w times w plus 4. So that common factor of w has been divided out of both terms, put out the front, and I'm left with w plus 4. Okay. So moving on to this one. All right. So as you notice, okay, we can start using variables with indices. So maybe you've had some experience factorizing using the highest common factor before, but maybe that was just with numbers. Now we are using indices to do this. Okay. So factorizing this expression, feel free again to write it in the chat box. Okay, but the first step is to find the highest common factor of these 2 terms, z squared and 8z to the power of 4. Okay, so I can see there is a z on both sides of the equation. Okay, and so what I can do is I can actually take z squared out as a highest common factor. So the highest common factor is z squared. So now factorizing this, z squared plus 8z to the power of 4, okay? When you take out z squared out the front, well, I know z squared times 1 creates z squared, right? So when you divide z squared from z squared, you're only left with number 1, okay? Whereas with 8z to the power of 4, if you divide z squared, you have to remember that z to the power of 4 divided by z squared, you're using that second index law. Z to the power of 4 minus 2, and that becomes z squared left in the brackets, okay? So I'm going to have plus 8z to the power of 2, okay? So careful, I think some people had that as a 4 and not an 8, okay? There was no number to factorize out the front, okay? And so you're left with that 8 in the second term, all right? So the answer is actually z squared times 1 plus 8z squared. And so that is that expression completely factorized, all right? Okay. All right, next we're factorizing this expression. So it's getting a little trickier, okay? It looks like I've only got the same 3 students really only answering. So Yusuf, Ray, Remy, yeah, you guys are really answering a lot, but not so much everyone else. And I know that there are other people here, okay? So I really appreciate those of you who are, you know, answering and, you know, you're getting the questions right. You know, you clearly know what you're doing. But for those others of you who are here, I won't read your names, okay? But I do encourage everyone to give it a go, okay? And even if this is a new concept for you, it looks like some of the guys here have done this before, so that's why they're getting the answers right, okay, without me really explaining it. But for those of you who haven't done this before, I encourage you to follow along and give it a go. Yeah, so thank you, Chetna, well done. Yeah, thanks for speaking up. Okay, so let me do this one quickly on the board. I'll do it a little faster now. So the highest common factor, okay, well, 20 and 7. 7's a prime number and 20 is not a factor. There's no 7 factor there, okay? So in the brackets, I'm still going to have 20 something minus 7 something, right? And I can see both share H and J, right? So H and J appear in both terms, so I can divide them as common factors. So then I'm left with 20 times G. Okay, so that first term, 20GHJ, once I divide out H and J, I'm only left with 20G. And then with 7HJ, once I divide out HJ, I'm only left with 7. Okay, so this is actually my answer. Okay, and I can see a lot of you got that right. Well done. So this is going to be HJ times 20G minus 7. Great, well done. All right, so now let's factorize this, all right? So I want to give you all a couple of moments to answer this. If you don't know what the answer is, you could at least attempt to tell me what the highest common factor is, okay? So I want to see in the chat box, everyone either writing the answer, if you know how to do this, or you can just write the highest common factor. So you could write, if I'm going to do it in the chat box, if I didn't know how to do this question, I might write what the highest common factor is. I know it is negative W as a clue, okay? So if you just write HCF equals, and then you can tell me the highest common factor, or if you know the answer, you can tell me the answer. So, yep, Yusuf and Yusuf, there are 2 Yusufs here today. You've both got it right. Ray, you've got it right. Okay, so let me quickly do it on the board. So I gave you the answer before in the chat box of the highest common factor. The highest common factor of negative W squared and negative 4W. All right, there is actually a factor of negative 1 I can take out. So if I divide both terms by negative 1, okay, I can actually cancel out the negative. Right, so a common factor is negative 1. And then, of course, there is W. So I saw W written by some people in the chat as that highest common factor. And then so the highest common factor would just be the multiple of those, so negative W. Okay. Yusuf, would you be able to call me Yusuf N just to differentiate? Sure. Yep. So Yusuf N and then Yusuf E, I think the other one was, wasn't it? Sorry, other Yusuf. Yes, Yusuf E. I won't do Yusuf 1 and 2. I'll do Yusuf N and Yusuf E. Okay. So yeah, the highest common factor is negative W. So once you divide out negative W from both terms, you are left with, so negative W times W would give you the negative W squared, and then you have to add 4, okay? Because then negative W times 4 is negative 4W. So that is the correct factorization. Okay, so if both terms have a negative, it's a good idea to divide it out. Okay, it just makes the expression more cleaner. All right, so we'll do another one. We'll only do a couple more of these and then we'll move on to some harder factorizations. Okay, so factorizing this, 6k squared t plus 48k cubed t cubed. All right, so if you don't know the answer, you could at least attempt to find the highest common factor. Otherwise, if you know the answer, you can write it in the chat box. So just to give you guys a hand, 6k squared t and 48k cubed t cubed. 48 is a multiple of 6, so I can actually divide 6 from both terms. Okay. Close. Yusuf E, close, correct Yusuf N, correct Ray so far. Okay. Remy, that is correct. Yes. Yeah. Okay. So you can also divide out t from both sides. Okay. You can't divide out t squared or t cubed because you've only got the one t in the first term. Okay. And you can also divide out k squared from both sides. You can't divide out k cubed because you've only got a k squared on the left-hand side. Okay. So then that highest common factor is going to be the product of these terms. So 6k squared t, or you could write 6tk squared. That's fine. Okay. Yep. So well done. Yusuf E, that's the correct highest common factor. So then the answer, taking out the highest common factor out the front, okay, what you're going to be left with is only number 1 for the first term, because we've divided everything out of the first term. And then we're adding, well, 48 over 6 is 8, k cubed over k squared is k, t cubed over t is t squared. So then this becomes that final answer. Okay. So that was a trickier factorization again. Now we're going to work on taking out a highest common factor when you have more than 2 terms, when you have 3 terms, okay? So this is a bit trickier, all right? And we're actually probably going to need negative indices as well. So part A, what is the highest common factor? This question's breaking it down for you, okay? So first we're just looking at the 3 numbers, yeah? 21, 30, and 15. What's that highest common factor? So don't look at the top, at the letters for now, just look at 21, 30, and 15. So I just want a few people to answer this. So if you remember your times tables, you might remember these 3 numbers appearing in that one group of times tables. So what is 21, 30, and 15 a multiple of? Arnold, Remy, Yusuf N, Ray, correct all so far. Yep. Yusuf E, correct. Good. So I'll just give you all a couple of moments. Yeah, so the correct answer is 3, okay? So the highest common factor is equal to 3, okay? So remember 21 is 7 times 3, 30 is 10 times 3, 15 is 5 times 3. Okay, before we continue, guys, and I'm actually going to stop sharing my screen for a moment, and I might share a whiteboard quickly. Okay, I've actually had a really good question in the Q&A that I would like to address. All right, and so it's a really common question. Why are we doing this? What's the point of taking letters out the front? Like, what's the point? What's the point of algebra? Why are we doing this? So this is a really common student question, okay? All through high school mathematics, especially. You know, it gets to a point, you know, in year 9 when you think, why do we need to know this? I might not never use this in my life, okay? So I've got several answers for this, okay? And I will be quick. We'll get back to the question work in a moment, okay? When you start graphing in the future, okay, and graphing is a really good way to model real life problems, all right? So once you know that a problem, you know, it might be a quadratic, for example. Let's look at 16x plus 4x squared, okay? And you need to find the x-axis intercepts, okay? So to find the x-axis intercepts, you let y equal 0, all right? So then 0 is going to equal 16x plus 4x squared. And then so if you can take a highest common factor, all right, you can then use what's called the null factor law to find the y-axis intercept, okay? So x could equal 0 or x could equal -4 to make this equation equal 0, all right? So you might have seen highest common, not highest common factor, you might have seen the null factor law before, okay? The null factor law is that if you've got two numbers that multiply together and they equal 0, you know one or the other must be 0, okay? So it is the null factor law in algebra, okay? So that's how I was able to say, well, then this must equal 0 or this must equal 0, one or the other, okay? And then if 4x is equal to 0, well, then x has to be 0. And then if 4 plus x is 0, x has to be -4. So then when it comes to graphing this, okay, and I'm really jumping ahead, guys. We're going straight into like year 10 maths here, all right? So you then know you've got these axis intercepts, and then you'll recognize this as a parabola eventually, and then that parabola goes through those x-axis intercepts. So it then helps you visualize these problems, okay? So that's one reason, okay? It becomes very important when you're graphing, okay, to be able to do this algebra work, okay, in order to graph, right? You need to be able to factorize in order to be able to find x-axis intercepts of graphs. Now, another question I get in class would be, well, why do I have to know that? Why do I have to know how to graph these functions, these problems, right? You know, maybe you have a job that you see that you would like to do in the future, which doesn't require that kind of level of mathematics knowledge at all. And that's an interesting point, okay? But what I say to you is that if you can do maths, right, you train your brain. You get very smart, okay, and you become a problem solver, and it's a certain area of your brain, okay? It's not the be-all of end-all. There's plenty of other forms of intelligence as well. But the longer you can stick through maths, you build a resilience, you build a confidence as well. You know, if I can solve a quadratic equation, what can't I do, right? So there is a lot of reasons to stick through this maths. And I know when it comes to the skill building, like we're doing today, when it's not particularly around solving real problems, it can be frustrating. It can be boring. It is very common, you know, students all around the world, you know, hate algebra, okay? But if you stick with it, okay, and you learn to understand it, then you train your brain that so when you learn other more difficult concepts in life, okay, it's something that you have the patience and the resilience to stick with, okay? So yeah, I really wanted to tackle that question because it is a common one in the classroom that teachers get asked, why are we doing this? What's the point? Okay, yes, there are calculators that can do all this stuff, but you know, what if you don't have a calculator? And what if you are in a career, like a STEM career as an engineer or a scientist that, you know, pays a lot of money and you need to have that maths background, okay? So for some of you who have that aspiration, you know, this maths is really important. But if you're not looking to go into a STEM career and maybe you're going into a career that doesn't require much mathematics knowledge, that's fine. And I wish you all the best in the world and all the success and happiness, but this is still important to stick with, you know, all the way through high school, so that then at least when you come out of high school, you know, you've trained that brain, big brain, as Ray says. Yes. All right. So I hear you. I know it's not always fun, especially the skills building stuff, but if you keep with it, you'll start to see more of the applications work later, and you'll then have these aha moments like, oh, that's why we have to factorize. So now that we can graph. Okay. All right, I'll shut up now and I'll go back to the problem solving. So we found that highest common factor of 21, 30, and 15 to be 3. Okay. Now we need to look at the algebra terms. So we've covered the numbers. We're now looking at the algebra terms. So you tell me, guys, what is the highest common factor of p cubed r squared t cubed, p squared r cubed t squared, and r cubed t squared divided by p? All right. So if I look at p cubed r squared t cubed, p squared r cubed t squared, okay, and then r cubed t squared over p, okay, I can see r squared can be divided out of every term, okay? So with r cubed, I could divide out r squared. Okay, I also see there is a t squared, all right? So t squared's in this term, and then there's a t cubed in this term. So I can divide out t squared from every expression. Now the last one's tricky. What do we do with the p, right? See, I've got p cubed, I've got p squared, and then I've got p. The problem, if I divide out just p, okay, is that this would become p squared, this would become p, but then this would become p squared at the bottom, right? So that's a tricky one to factorize. What you could do is you could divide out p to the -1, or it's dividing 1 over p, which is the same as multiplying by p, okay? So I would say that the highest common factor is actually the product of, okay, r squared, all right, t squared, and then divided by p. I would take this out as the common factor, all right? Let's see what the question says, because it might actually not do anything with the p, and that is an option. You could just leave the p in there, okay? But I would actually take the p out. So r squared t squared divided by p. Yeah, so Mathspace is actually making this a little easier on us. We don't need to take out the p, okay? So the only reason why I would factor out 1 over p is so that then I don't have any fractions appearing inside the brackets, but that's an optional step. So let's just leave it at r squared t squared, and that's good enough. That's correct, okay? So I'll show you at the end the benefit of taking out 1 over p, but for now, let's just use r squared and t squared, okay? So then the next part of the question, well then what's the highest common factor of these 3 terms at the top? Remember we were looking at these numbers, okay? So it would be 3 times r squared t squared. And so multiplying these together, it would be 3 r squared t squared. So yes, Yusuf, N, Yusuf E, Ray, that was correct. You beat me to it. So that's how you can take a highest common factor out of more than 2 terms, out of 3 terms, okay? Now, if you took out a highest common factor of 3r squared t squared, and then you divided by p, okay? And then let's say these terms were all being added together, all right? Well, then I would have left over 7p to the power of 4 times t, okay? So I've got to add 1 to this power of p because I've divided out 1 over p. I've divided by p to the power of -1, which remember is the same as times in by p, okay? And there's still a t left over from the t cubed. The second one, okay, I have 10, right? P squared is going to become p cubed, right? And then I have an r left over, right? Because of that r cubed and the t squared's gone. And then adding then 15, so that's 5 r, and then because there's still r cubed, right? And then there's that t squared, but then there's no p, right? Because I took out the 1 over p. So that's a tricky one, all right? That would have been my answer if you followed my instruction to divide out p. And the benefit of that is now I don't have a fraction in that third term anymore, okay? But this question's been set up for year 9 students, all right? That's probably a year 10, year 11 level factorization to take out the 1 over p, all right? At the year 9 level, it would have been acceptable to not divide out the p if these were being added together, okay? And then you would have left this as p cubed. You would have left the second one as p squared. And then in the third term, you would have had divided by p, and that would have been fine, okay? Great. All right, let's go to the next question. Still got plenty more to work on today, and I might start skipping a few. So factorizing this, okay? Now from these 3 terms, we need to find the highest common factor and then give my answer. So I can see letters P, Q, and R appearing in all 3 terms. Now, because the first term only has P, Q, and R on its own with no powers, that's the highest common factor I must take out, P, Q, R. So then my first term will be 1, okay? No one's written the answer in the chat box yet. For P squared, Q squared, R, I can take away 1P and 1Q, and then the R is gone. And then for P cubed, Q cubed R, okay, I'm taking 1P, dividing it out, dividing out 1Q to leave Q squared, and then again the R is gone. So yes, everyone seems to be getting the answer now. Well done, both Yusufs and Ray. Very good. So yeah, that would become the answer when taking out that highest common factor, PQR. All right, now we're going to start to look at grouping as a factorization. So actually, first, I might go back to my slides and let's just revise what we were doing last week with binomial expansion. Okay, so with binomial expansion, remember I proved it by letting x equal a times a plus b, and then I did all this work to show this proof of binomial expansion, okay? Yep, so I'm just going to skip through all this work, okay? This is just some slides from last week. You can revise last week's recording if you weren't here. Okay, so we got that using the FOILS method, you could do binomial expansion. Now, we're not going to factorize too many binomials because that's quite tricky, okay? All right, but I just wanted to show you this because it's helpful when we look at this question, okay? So when we look at 5 times a plus b times v times a plus b, what if you let x equal a plus b? Well, then 5a plus b plus v times a plus b that would just equal 5x plus vx. And then that highest common factor would be x. So x times and then 5 plus v. So now I can replace x with what it's supposed to be, a plus b. So I get this answer of a plus b times 5 plus v. All right. I can see the chat box blowing up. I can see a few people getting that right. So I'm factorizing the question. So I think a few people decided to expand. Okay. Now, that's not what the question was asking. The question was asking to fully factorize, not to expand. So if you expand, yeah, you just use the highest common factor twice and then you do it, right? But if you're factorizing, you can find the highest common factor in both terms. And that highest common factor in this case was the sum of a and b. So I can see a plus b appearing in the first term and a plus b appearing in the second term. So I could take it out as a highest common factor. And then what I'm left with, the 5 and the v, appears here. Okay, so this is just an extension of our highest common factor work. All right, so if we keep going, I won't bother put that into Mathspace. Okay, now I want you guys to use this concept to factorize this. X times y minus z minus w times y minus z. Okay, so I want you now to factorize this. You have to identify the highest common factor and then take it out the front. Yusuf N, that is correct. That is correct. Well done. Ray, yes, that's correct as well. So what some people are identifying is that the y minus z is the highest common factor. Okay, yes, Yusuf E, well done. Okay, so the highest common factor is the difference of these two terms, y minus z. So it can be taken out the front, right? So you can divide it from both of these terms. So then you've got y minus z, all right? And then what you're left with is the x minus the w, okay? Dividing y minus z from the first term leaves x. Dividing y minus z from the second term leaves w. All right. Let's keep going. So now I want to factorize this. This is a little trickier, right? Okay, I want to see if some of you could get the trick here. Pardon me. So it doesn't appear there is a highest common factor, not at least in this form. So I can confirm no one's got the answer right yet. So someone's given me an answer. It's not correct. Yes, that answer is correct, Yusuf. Yeah. So with 9 minus y, how could I make it equal to y minus 9? I would have to multiply by -1. -1 times the 9 makes the -9, and then the -1 times the -y makes the +y. Okay? So I would first write this as 9y times y minus 9, leave that first term as is, but then instead of +4, I would do -4 times y minus 9. So writing it in this form, now I can see that highest common factor, it is y minus 9. And then so I'm left with 9y minus 4. Okay. So that is the correct answer. So actually, yeah, I said someone's answer was right before, it actually wasn't. So yeah, that's how you would do this problem, okay? So sometimes you've got to maybe multiply by a -1, for example, so that then you can clearly see the highest common factor. All right, now we're going to factorize by grouping into pairs, okay? And so sometimes these pairs come out like this, okay? They come out so you can pair these together and then pair these together. So you're finding the highest common factor twice. So with x squared and 3x, group that into a pair, and then the 5x and 15, and group that into a pair. So if x squared and 3x, the highest common factor is x, okay? And then 5x and 15, the highest common factor is 5. Right? So then I'm going to get x times x plus 3, factorizing that first pair, and then 5 times x plus 3 when I look at that second pair. Well, yes, lo and behold, I now have a common factor, a highest common factor of x plus 3. So I can take x plus 3 out the front, and then I'm left with x plus 5. So yeah, use of E, I see you got that right. Yeah, I can see some of you other guys are putting in the answer correct as well. Yeah, Ray as well got it right too. Well done. Good. So this is another type of factorization that you can do. I think if you're in Victoria, I don't know if they cover this in Year 9. I think they actually don't do much factorization at the Year 9 level, okay? But in other areas of Australia, if you're following the Australian curriculum, in Year 9, you would be required to do this, okay? So let's try again, factorize this expression by grouping into pairs. So I want you all to group these two terms together and then also these two terms together and try take out a highest common factor. Okay, I'll give you a clue. I would group these together and then I would group these together. So I would include that negative as taking that out as a highest common factor, right? So with 6x plus xz, okay, we can take out a common factor of x to leave 6 plus z. All right, and then if we look at the negative 18y minus 3yz, I could take out a highest common factor of negative 3y. And that will leave me with positive 6 plus z. So now I have that highest common factor of 6 plus z, okay? So then I'm going to get 6 plus z times x minus 3y as the answer. Okay, so this is more factorization by grouping. I might have one more in here that we can do. Let's do a harder one. No, I won't do any of these. Oh, is that it? I thought I had more. Okay. Actually, no, this is good. This one is good. Let's do this one. Okay. This one's trickier, okay, because if I group these, I could find a highest common factor, but if I group these, there is no highest common factor. So if I look at 3p and 16m, there is no highest common factor that can be divided out. 16 is not a multiple of 3, okay? So sometimes when you group into pairs, okay, sometimes it's better to reorder the sum. So I would swap, I would swap some terms around. So I would look at 4mp and then plus 3p. Okay, and then do 16m plus 12. Okay, so swapping some of these terms around, then group other pairs, right? So in these first two numbers, 4mp and 3p, I can do then just p to be left with 4m plus 3. And then in the second two terms, I can take out a common factor of 4. So then I'm again left with 4m plus 3. So now I have found my highest common factor by rearranging, by grouping different terms. Because remember, it doesn't matter what order you add numbers together. If they're all being added, you can add in any order you like, right? 1 plus 3 plus 2 is the same as 3 plus 2 plus 1. So now I've taken out a highest common factor of 4m plus 3. So then I'm going to get p plus 4 times 4m plus 3. Or you could do it the other way around. Okay. Yeah, so I can see some of you guys actually managed to get that. So Remy, use of E, yep, well done, good work. Okay, so I'm actually going to finish there, all right, because we're almost out of time. There was some other work that I was going to do, but let's cover it at the start of next week, okay, because I actually don't need a full hour for Pythagoras' theorem. So what I want you to do, okay, and you need to bring this work to me for next week, all right? So remember, and I'll give you a clue, all right? I want you to derive a formula that's called the difference of perfect squares. And I've given you the first step, okay? So I want you, where this is now practice more about last week's work as well, and we're going to use this to factorize, okay? So I want you to use binomial expansion to expand a plus b times a minus b. All right, so I'm actually writing this homework in the chat box. All right, and so I've actually given the first step of work there, but I'm actually going to go to the next slide. Okay, I don't want you to see this. I've just kind of given that away then as well. All right, I want you to factorize a plus b. Sorry, not factorize, expand. Expand. I want you to expand a squared, a plus b all squared. Okay, whoops. Okay, I want you to expand a plus b all squared. And I also want you to expand a minus b all squared, okay? That's your homework, all right? So I'll write the other one underneath as well. Expand a plus b times a minus b. Okay, so I want you to expand these three. Okay, some of you are getting it already. Ray, use of N. Yep, your answers to some of those are correct. Okay, but let's bring this to the work next week. All right, but also that problem at the start, the challenge problem. So what I'll do is just quit presenting mode. Where to go? Algebra, factorising. Okay. So I'll just put up that challenge problem that I did at the start as well, okay? So I also want you to expand this binomial expression, all right? So because you were following along with today's work, I'm not surprised if, you know, no one got it, okay? Yep, use of N, that's correct for question 1 and 2. But I'm leaving that, you guys can tell me this again next week, all right? Because I'm not going to remember who got it now and who got it later, all right? So do those questions that I put to you in the chat box, and also give me this answer as well, expanding this binomial expression, all right? So I'm going to go now, all right? So hopefully you had a chance to write this down at the start of the class. If not, okay, write it down very quickly now. If not, you can look at it in the recording tomorrow, okay? So there's your challenge question. I know I had some of you ask me for challenge questions, okay? So that's the challenge one, and then also some of those homework questions that I wrote in the chat box as well, all right? Before I go, I'll just very quickly look at the Q&A. I know there were some more questions in the Q&A still. I answered, why do we need this? Someone else, why do we need to know this? I've answered those. How many people in the group? Today, I think we had about 8 of us, okay? So yeah, I think there were about 8 people in the group, so pretty small today. Hopefully those numbers grow as the weeks go on, okay? We're gonna do a bit more of a push on our side at Mathspace to get the word out so we can get more kids coming along, more students. Yep, so I just answered that question as well. What's the next topic that we will be covering? It's Pythagoras' theorem, okay? We'll spend about 10, 15 minutes finishing factorization because I didn't get through quite everything today. And then we're going to talk about Pythagoras' theorem next week, all right? Ray, do you believe that numbers have an end? No, there is a concept that's called infinity, okay? So you can never have too large or too small a number. We can talk about that another day. Yusuf E, did you know I am in year 8? No, I didn't. Good job. Glad to have you here. How many lessons will be there of Pythagoras? We'll be doing 2 lessons on Pythagoras' theorem next week and then the week after. Someone asked, do we do it now? The homework? No, do it over the next week and give me the answer next week. Finally, how can you tell whether to do either 1 or a single pronumeral when x is equal to 1? E.g. in that question, negative w squared minus 4w, you did w rather than 1, right? So, I mean, technically every number, Remy, if you're still here, has 1 as a common factor, but there's no point dividing 1 out because it doesn't do anything, right? So, yes, so if I have like w plus 4w squared, all right, you could take 1 out as a common factor and then you just have w plus 4w squared, right? So it doesn't actually achieve anything taking 1 out as a factor, right? So that's why we don't typically do it. Even when you take out -1, like I did in that question, note I didn't take -1, I just wrote negative out the front, okay? Great. Another question, do you teach at a school? No, I used to teach at Swinburne University, okay, and I have tutored for many, many years, but I'm not working currently at a school, I am just working at Mathspace. Thank you for the compliment. You're really great at teaching. Thank you so much. My pleasure, whoever wrote that. That's very nice of you. Thank you. All right, I better get going, guys. So thank you very much, everyone, for coming. And yeah, hope to see you all next week. See you later, everyone.